Thank you. Good morning, everyone. I'm very glad that we have the previous presentation because these two talks are quite connected. And what I would like first to do is to acknowledge my co-authors, Tatiana Ross and Frank Whitney. And what I'm going to talk today is about some anomalous biogeochemical conditions that we observed in 2019. And I will try to see what data is available to try to explain these anomalies. So I will start just with a small introduction about the Northeast Subarctic Pacific. One of the main features of this region is that as is shown here, is that this is what is called a high nutrient, low chlorophyll region. What it means is that micronutrients are usually abundant year-round in this region, and there is usually a small phytoplankton biomass. And the phytoplankton biomass doesn't show really a seasonality, but it's relatively constant. There has been many studies and many projects and process studies in this region to try to explain what produced this high nutrient low chlorophyll region. And the consensus is that this is due mostly to two reasons. One is grazing control, because in this region, the winter mix layer is not deep enough to uncouple the zooplankton and the phytoplankton. And in this region also, the phytoplankton is very small, usually less than 10 micrometers. So the phytoplankton and the microzooplankton are really well coupled, and that maintains the constant phytoplankton biomass. The other hypothesis, and they are not really exclusive, or each hypothesis doesn't exclude each other, is that iron limitation is limiting the growth of phytoplankton, because we know that there is the input or the deposition of iron in the Northeast Pacific is quite low, so iron is limiting the growth of phytoplankton, and iron enrichment experiments have been carried out in this region. There was a mesoscale experiment at OSP in July 2002, which showed that if you add iron to the water of this region, you can get an increase in phytoplankton biomass, as can be seen here in the satellite data. So this experiment has been quite conclusive in showing that iron is the limiting nutrient to phytoplankton in this region. So what I'm going to do now is show some observation mostly from the Line P program. Jackie mentioned already the Line P program is a line that goes from the coastal region just off the Juan de Fuca Strait to Ocean Station Papan in the Northeast Subarctic Pacific. I have sort of marked here the stations that are in the high nutrient, low chlorophyll region of Line P. Sampling started in the early 60s, late 50s, with mostly physical measurements, and biogeochemical measurements were added in the later year. And at present, Fisheries and Ocean Canada sample Line P 3 times a year at 27 stations. So the main observation I want to discuss today and present is that in 2019, and here is the Line P, here is the nitrate and the silicate concentration. And as you can see here in this blue line, in 2019, in the summer of 2019, we saw for the first time nutrient levels at Ocean Station Papa, and actually in all these high nutrient low chlorophyll regions that were well below what has been observed in the previous 60 years. So at the same time, we saw lower silicate conditions at some of the stations, but not at Ocean Station Papa. Here I'm just showing the same sort of observation in a different way. And what is here is the longitude. So this is the longitude of the station along Line P. This is Ocean Station Papa. This is the coast. And we see that these are the station marked here, the color show the station that show nitrate concentration that were less than 1 micromole, and in the silicate less than 2 micromole. And as you can see here, in 2018, nitrate depletion was really quite far offshore that has been observed. I'm here showing only the last 30 years of record, but if you go back to the last 60 years, this is the first time we have observed this low nutrient concentration at Ocean Station Papa, and actually, so where is my cursor? And actually at all this high nutrient low chlorophyll region. In terms of the silicate, we have seen years that we see more silicate depletion, and the silicate is a bit different history than the nitrate. But one thing that is different in 2019 is that we see depletion of silicate in a much broader area than in previous years. So the main thing I would like to discuss and present some observation is to see why nitrate was depleted in 2019 in the high nutrient low chlorophyll region. This was really an unusual observation, and it is not simple to see why it happened, but I will try to. I think there are mainly three factors that could be affecting the concentration of nutrient in this region. One could be that the nutrient renewal in winter was low due to the increase in upper layer stratification. We saw that nutrient renewal was low during the blob years of 2014 and 15, and this could have just, the fact that nitrate was low could have been just because there was low nutrient in winter and was low enough that all was utilized by phytoplankton. A second possibility is the phytoplankton consumption was higher than in other years, leading to this nitrate depletion in summer. But as I mentioned before, it's not nitrate the one that limits phytoplankton utilization, but it's iron. So to consume all the nitrate, if the nitrate was in usual concentrations in winter, we need to find why iron was increased at the time. And here are the 5 different possibilities of 5 processes that could bring iron to the region, and transport by eddies and volcanic ash eruption, and then transport by the atmosphere has been observed in previous year at Ocean Station Papa. So we know that these are a possible reason for iron being supplied in this region. The other possibility is that the blob and this unusual condition in the last few years are changing the remineralization depth of particles, and particles are being remineralized at shallower depths, and the nutrients are being more available for phytoplankton. Another possibility is that there was a change in the circulation, and this change in the circulation brought iron-rich waters to the region. It could also be a combination of the last two, so C and D. Or the other possibility is that these changes in circulation brought waters low in nitrate to the region. So I will go to all these possible causes and try to see what the data available show. The first one is that the nutrient renewal in winter was low due to increase in the upper layer stratification. And here is the density from Argo float from 2004 to 2020. And we can see that the denser isopycnals haven't been really reached the surface in the last few years. And in 2019, shown here, the isopycnal was quite deep, and we don't see really this renewal of nutrient. Dense water at the surface, similar here in 2014-15, and here in 2019. in the winter of 2019. And here is just another plot showing the surface density at Ocean Station Papa, just to show that the waters were quite warm. They were low density warm waters in the winter and the summer of 2014 and 15 and 2019. So as the main source of nutrient to replenish the upper layer is below the main picnogram, this increase in stratification could have restricted the winter transport of nutrient in all these years. However, when we look at the nitrate concentration from observations, and here is in winter, spring, and summer, one thing that called the attention is that the nitrate in winter were much lower in 2014 and 15 than in 2019. So even though stratification was similar in 2015 and 2019, we got more nutrients in 2019, in the winter of 2019, and in 2015, we didn't see a depletion of nitrate like we saw in 2019. So just these changes in the stratification of the upper layer doesn't seem to explain the lower surface nitrate concentration observed in the summer at Ocean Station Papa. So we can look at the nitrate utilization, just a simple calculation just to see what was the difference between the nitrate observed in February and the one observed in August. And the difference in 2019 was higher than in the previous years, in these previous 13 years. So this indicates that nitrate was not in low supply in 2019, but there was more nutrient being utilized in this year compared to previous year. The silicate is more complex, and we see that actually the highest silicate consumption occurred in 2008, and this was a year that we know there was a volcanic ash event that brought iron to Ocean Station Papa and produced a phytoplankton bloom. So let us look now at the phytoplankton. Here is a plot of the time series of chlorophyll concentration at defined high neutral low chlorophyll regions of line P. And we see that in 2018, chlorophyll levels were higher than is supposed to be the usual. I mean, before this blob year, we will say that phytoplankton was generally less than 0.5 microgram of chlorophyll. In recent years, since the blob, we have seen this phytoplankton biomass increasing at times. And again, this was the volcanic ash event. So in 2019, there was higher biomass, and this biomass could have consumed the nitrate that was available and produced the depletion of nitrate. This is just to have a look at the composition of phytoplankton. So these are the different phytoplankton groups that we have been observing in recent years. And we can see that at some of the high neutral low chlorophyll station, there was increase in diatoms, but not an Ocean Station Papa in the summer. In June, the composition of phytoplankton is similar to what we usually have been observed in previous year. That is that most of the phytoplankton is dominated by haptophyte. But these are only, observations 3 times a year. So we are fortunately that this float that Jackie mentioned was sampling near Ocean Station Papa in 2019. And when I look at the values, when I look at the data, and here I'm just marking the time of the August cruise, the Line P cruise, one thing that we can see is that this nitrate depletion here is confirmed by the float data. These are Argo float that have biochemical sensors, and they show that the nitrate was really low, and this depletion of nitrogen happened before our cruise, and this could explain the lower diatoms that we observed in the summer, because we were, at the time we sampled, there was nitrate depletion, and most likely phytoplankton was limited by nitrate availability. We can also see that the oxygen here was increased, and then it seemed to in the spring, so there was an increase likely in the production in the spring. And we can see from the chlorophyll that chlorophyll was also enhanced in the spring summer around here, and it seemed to be sinking of phytoplankton since the maximum is at the subsurface. What I'm showing here is just the same flow data, but now I'm just showing profile during near the time of the sampling from the line P cruises, and here are the profile for the line P cruises. Here is for nitrate density and the chlorophyll in the float, and the chlorophyll from the cruises. And what the flow data is showing is that actually nitrate depletion occurred around the 11th of August. Our sampling was at the end of August, about the 26th of August. So around here, so we can see that nitrate occurred in this time period. The other thing that we can see is that there seems to have been deepening of the pycnocline and nutricline in April. So, and maybe that's, we got likely more nutrients than we were observing in February, because the deepening of the pycnocline happened later. Usually the pycnocline is deeper in March at Ocean Station Papa, but this year seemed to have been in April. Gonna move to the next slide. So this was observation. So the low nitrate concentration, high phytoplankton biomass, increase in the abundance of diatom, they all point to an increase in the consumption of nitrate. And this increased consumption of nitrate most likely was the reason that nitrate was depleted in the summer of 2019. So, as I mentioned, for phytoplankton to consume all the nitrate, iron needs to be increased in the region, because iron is the limiting nutrient. So one process that brings iron to the Nordic Pacifics are mesoscale eddies. And I'm going to show you here a little movie of the altimetry data showing that, very quickly, showing that in general, we don't see much eddy activity in 2019. So there seemed to be one small eddy approaching line P from the northeast in late summer, but most likely did not supply iron to Station Papa. And here is just another way to show the data in case the movie didn't work. It was just this flat dot show the maxima in the absolute dynamic topography over time, showing that really not much seemed to have happened at Ocean Station Papa. Now, with respect to volcanic ash, we saw an increase in volcanic ash in August 2008. This caused a bloom of phytoplankton, but in 2019, we are not aware of any volcanic eruption in the area that could have brought this iron to the region.
Angelica, just letting you know you've got about a minute or so left.
Yes. So one of the most likely process for this increase in iron is the increase in remineralization, mostly at these steps. Here we show the difference in the density at the pycnocline, and during these warm years, we have the pycnocline is sharper and this could have trapped particles that usually sink below the pycnocline, and these particles, especially in the year before, and these particles will be remineralized, providing nutrients and iron that can be used the following years. Another thing we have seen is that there has been changes in the circulation in the North Pacific. Here I'm just showing that the MPGO was quite low in 2019. I'm also here a plot of the bifurcation. We look at the bifurcation of the North Pacific current, and it seemed to have been quite further north compared to 2015 and 16. In addition, we saw low salinities at the surface and relatively low dissolved oxygen. So we don't know if these changes in circulation could have contributed to bring iron-rich waters to the high neutral low chlorophyll region. Most likely, these changes in circulation did not bring low nutrients, low nitrate waters, because we have seen that nitrate was really not that low. So just to summarize, nutrient renewal was low in winter due to upper stratification. We can say no, that's not the main reason why we don't see nitrate in the summer of 2019. Phytoplankton consumption, yes, that's the most likely reason why nitrate was depleted. There are no clear transfer from eddies or volcanic ash eruption. So local biological process, such as increase in local remineralization, is likely, and we don't know if the circulation could also have contributed to the increase in iron. But we know that the waters low in oxygen wouldn't explain this observation. So I would like just to finish acknowledging all the people that have participated in the Line P cruises